Welcome back. In this lesson, we're going to look at the concept of weathering. So when a rock is exposed to the elements, so say to the wind or the water or the weather, it can break down into smaller pieces. It's going to do this by two major ways. You're going to have a mechanical weathering, which is breaking rocks down into smaller pieces, and the composition of those pieces will be the same as the composition of the rock. So simply crushing a rock into pebbles, you're still going to have the same composition. That would be mechanical weathering, and there's several different ways that we're going to look at that happens. You're also going to have chemical weathering, where there is a chemical reaction occurring, usually with some kind of an acid that's in the rainwater or in the groundwater. And as that chemical reaction happens, you are going to change some of the structure of the minerals in that rock. And so there may be some differences at the end than you would at the beginning. You've actually have new substances because you've had a chemical reaction. In any case, those rocks can now then be broken down into either different components or smaller components. And then erosion, which is different than weathering, erosion then transports that away. So you can erode by wind or water, or other things can take away soils and rocks and fragments. So we're going to look at this concept, which is essential to the idea of sedimentary rock, because sediments have to be made of these small pieces that eventually or at once was broken off of a larger rock, mountain, etc. So let's take a look. Weathering, of course, comes from the word the weather. So you've got rain and a lot of wind and stuff like hitting against things. So if you can get water in between the cracks of a rock, you can do a lot of damage, especially if that rock gets cold and the water turns to ice. So we can see that as a possibility. You're going to have so there's other ways to break that rock. So you could have, there is shifting that can happen, and when that happens, pressure can create great forces on rocks and break them simply by packing. You could have trees and roots of trees especially that could get in between rocks and break them apart. So various types of mechanical devices where it breaks it actually into smaller pieces. That's a type of weathering. We're going to look at that. And then the second type of weathering is chemical, where you actually have some kind of a chemical reaction going on, normally with acid, and as it breaks apart or changes the composition of certain rocks, you can end up with other layers or smaller parts or particles that could be compressed later into rocks. Very closely related idea is erosion. So erosion would be the transport of these small particles. So imagine wind can erode things, or animals burrowing through the ground can break apart things and move those particles. Water especially, streams. Anytime the water is running across the soils, it can carry the soils down. And then those particles are basically being carried lofty in the water. It's called a load, and as it carries it away, then it's transported away. So that's called erosion. So you have the weathering, which breaks the rocks apart, either chemically or mechanically, and then some type of erosion that carries it away, transports it. So if you're talking about mechanical weathering, anything that breaks it into smaller pieces, what to keep in mind is that it's the same stuff. So you have a big rock, and then after it's been mechanically weathered, you've got the same material, you've just got smaller pieces. Then the smaller the pieces, the more there is an outside compared to the amount of inside. Okay, so if you have a huge boulder, there's more inside than outside. Okay, so if anything were to happen chemically to that rock, it always happens on the outside. The smaller you make the particle, the more outside you have, okay, compared to the inside. And so, for instance, if you want to burn coal dust burns more violently than huge pieces of coal. Even though the coal burns, the smaller you make those pieces, the more surface area you have, the more likely that it is to react. Same way with chemical reacting. So many times two things are happening. It'll be broken down mechanically into smaller pieces, then broken down chemically later by different chemical processes. So I think of this almost exclusively for weathering. It's the idea of water getting in the cracks of a rock and then turning to ice. Because ice expands about 9% of what it was, 9% added to its volume. So since it has a bigger volume, if you have a certain amount of water that fills to the top of a space in a rock and now it expands, it's going to push that rock apart. And this is called frost wedging. Okay, a wedge, if you've ever cut firewood, you put a wedge in the crack in a log and then drive it in with a mallet, and it breaks the log into two parts. The same thing happens with rocks. And so the frost wedging, it would happen, say, at the top of a mountain. It breaks it apart and then falls. And this is called detritus or detritus, which is these smaller fragments that fall to the bottom of a hill. You'll see it on every time you have a high wall at a strip job or along the highway where you have rocks that have fallen down. A lot of this is because of mechanical weathering. Now, sheeting, I think of sheeting really only in terms of intrusive rock. Let's imagine that I have a pluton, which used to be a magma chamber, and above that pluton, it used to be a volcano. But over the years, that volcano has eroded, and now the magma chamber is exposed. All right. Well, while it was covered with soil and rocks and whatever was above it, that was pushing down on the pluton, on that magma chamber that's now solid rock, and it was holding it in equilibrium. Well, as soon as all that's removed, you have a pressure from the inside pushing out, but you don't have a pressure pushing down. So what happens is that you have an uplift, and this is called, we'll get this when we get to mountains. Some mountains are uplifted for this reason. If you have erosion on top, it counters the pressure being pushed down, and the pressure being pushed up is now unchecked, and it starts pushing up. Well, as it pushes up, it's pushing up in all directions, and it breaks apart the stone right on the outer edge. And it's breaking it in sheets, and that's why it's called sheeting. So if you see a rock face, Seneca Rocks comes to mind in West Virginia, where it was an intrusive rock that's now exposed. A lot of times along the top of edge, it'll sheet out, and you can just see that it will basically flake and then fall down. It's not necessarily ice. Ice could have been participating in with it, but it's the pressures coming in from the inside of the ground that isn't checked by the pressure of the dirt on top, and so it sheets out. It's basically like exfoliation. It's essentially what happens in your skin. This is why your skin fluffs off. Your skin is growing out, and it breaks off at the surface, just like this. So I already mentioned that tree roots are a big reason for rocks to break into smaller pieces. Okay, and then animals too. You can have even worms. So burrowing animals, moles, and anything that has dens underground can break apart rocks as they're burrowing, and then it increases the weathering and increases the chances, since it's smaller, for chemical weathering to continue to break it down. So it breaks down faster as it goes.